Hello everyone, for this video we're going to talk about naive space classification. Now what is naive space classification? It is a probabilistic machine learning algorithm based on Bayes theorem, which is a fundamentally probability theorem. It is a classification algorithm that is particularly well suited for tasks such as text classification and spam filtering. Nayspace is a valuable algorithm, especially for quick and effective classification tasks, and it serves as a good baseline model for comparing with more complex algorithm. Though it is a very easy to work with, but it has its limitation, like the assumption of feature independence is naive and may not hold in all situations. It can be sensitive to irrelevant feature. For the code, uh, let me just okay, here we are. We have namespace. We have taken all our the required modules. Here you can see that here the required modules. Then we have data. We have taken the data, so that as you can see there is a salary name data. We have read that data. We have taken all such procedures to get a clean data. I mean, we have checked for any missing values, if there is any. We have checked all such things, and finally we have come to determining the target variable and the predictor variables. So we have dropped the salary, which is the target variable, and assigned it to a new variable, which is y is equals to df salary. From this we would separate and then partition the data into training set and testing set, which you can see that we have done in this line. And then all after doing that, we would check for again the categorical values and numerical values, and if there is any missing values or not, here you can do from this. And then all the categorical values are changed into numerical values. Then finally, the first thing we would do is get a standardized value of all the things, all the training set and the testing set. So X training has been standardized. Then we would standardize the X test. Then we would create a data frame of it so that it could be another data set. And now finally initiate a model, which we have imported here. Okay, so we would take that and try to fit in the model, and to fit all the X train and Y train into the model and get a predicted value. Now obviously we have a model. To get the accuracy score of that model, we would take the accuracy score and model accuracy, then training set accuracy, then null set accuracy, where you can see here we got the final accuracy score. Okay, now on to the next thing, which is neural networks. Neural networks is just like is based on human brain. It is inspired by the structure and functioning of the human brain. Just like we have neurons in our brain, we here in neural networks we have nodes, which are then organized into layers. Okay. Neural network, in comparison to all the algorithm, is another powerful task, as it is used for pattern recognition, classification, regression, and other complex decision making processes. So for every image and speech recognition you see is where we use neural networks. It is done by neural networks. We have NLP, which is natural language processor, which also uses a neural network, and autonomous vehicle recommendation system. So all these things are managed by neural networks, as it is a very powerful uh, powerful technique to use. Onto the code. Firstly, again, we would let me just find it if I can. Where did it go? Okay, here it is. Uh, Again, we have taken all our modules. Here you can see we have taken all the pre-processing modules and stuff, and then we have taken the data, we have read it, we obviously we would check if there is anything missing, if it is, and then we would apply all those things, we would replace if it is required. I mean, we did all the data cleaning things here. Then we we included all the categorical values into the numerical values. Then finally, uh, um, after doing all these things, we have finally come to our uh, training sets and the testing set here. We have changed it, and our main focus is our target variable, which is income, and we would now standardize it. Obviously, the first thing in neural network again is standardizing thing. We would standardize and transform the things, which is X train and X test. Now uniquely we would unique values, so that this unique income is for getting the values as only one unique values. Then next is classifier, which is NLP, I mean neural networks main point. We could get the hidden layers from this, and then through this we would try to fit the X train and Y train. Then we after doing this, we created a plot. Here you can see we have created the figure here, and hidden layer neurons and color bar. You can see all the things that have been done, and through this we could say we have achieved our neural network model. Okay. For the next thing is clustering. Clustering is a type of unsupervised uh, learning technique where the goal is to group similar data points together. So clustering is main point is to cluster all the similar data points based on the certain feature and characteristics. These clusters are these data points are similar to each other but are very different to other clusters. Okay, in clustering, the algorithm is not provided with labeled example. Instead, it identifies pattern and structure within the data. I mean, obviously, unsupervised learning techniques, we do not know the end. We do not know the result of it. So we just have the data set. We have to find the trend and pattern in it, and to get our desired get a outcome of it outcome through clustering. And so instead of instead of the labeled examples, we have to identify the patterns and structuring within the data. The objective is to create cluster go in such a way the data points are within the same cluster are similar, but they are different to other data points in other clusters. I know. Then the first main and to achieve clustering, we have k-mean clustering, which is one of the most popular and widely used clustering algorithm. Where we partition a data set into k cluster, where k is a predefined constant. In this algorithm, we aim to minimize the variance within each cluster. Okay, on to the code. Let me just go with it. I think this is it. Yes, this is it. As you can see, again we have taken our modules. Then we read whole data set, drop the columns which are not required. Then we have taken a range. Okay, I've started taking a range from 8 to 1 to 8. Okay, then k-mean clustering. Obviously, k-mean means we need a predefined constant. So we have done that here. We have put that uh, k-mean in df. I mean the uh, data data inside this predicted value predicted function. Then that km would have an inertia k-mean as an attribute called inertia, and we take those values and put them into the within the sum of cluster scores. Okay, so inertia would put those variables into the uh, VWSs. WSSC would append and print. We would print that, and finally, printing this would get us our sum of cluster scores. Okay, so WCSS, which is the within sum of cluster score, would be printed through. How can we do that? We can create a plot again. Okay, so to by visualizing the data. So we firstly did the plot point plot, which ranges from 1 to 8, and within the uh, within some of cluster scores. Then the title was given, obviously the x label and the y label. Then we plotted. The n cluster was 5. 5 is our k, the predefined constant. Here 5 is our k, and then that 5 we have used here to get a prediction value. And finally we got a, here you can see this was the prediction value, this was the virtual values, and finally we get a number of uh, you know um, a plot. Okay, plot points. And np dot unique values would be set here in an array. So all in all, this was it. We have talked about namespace classification, we have talked about neural networks, and finally we have talked about clustering. And so with this we come to a conclusion. Thank you.